Scramble.
By 1964, Britain's nuclear V-force was at its operational peak. If required, over 150 Valiants, Victors and Vulcans could be scrambled from temporary airfields all over the British Isles. The aircraft could be airborne within 4 minutes. Armed with a blue steel nuclear missile, a lone aircraft had the capability to strike a mortal blow deep in the heart of Soviet Russia. This was the era of the QRA, Quick Reaction Alert. Royal Air Force Bomber Command reached its zenith in size and power during the last months of the Second World War. Night after night, hundreds of Lancasters and Halifax heavy bombers were sent to bludgeon the German homeland with millions of tons of bombs. Working in conjunction with the US Air Force, the Allied bomber formations laid waste to industrial, civilian, and military centers, playing a significant part in the eventual victory in Europe. But the cost was high. Despite being heavily armored and equipped with defensive weapons, the heavy bombers remained vulnerable. In contrast, the de Havilland Mosquito had shown remarkably high rates of survivability, despite being totally unarmed. The key lay in its ability to fly at high speed at altitudes that put it beyond the German defenses. In 1945, as the Allies swept across Western Europe and into Germany, many aircraft research establishments were overrun. American, British, and Russian scientists would all benefit enormously from the data captured from the Germans, who had explored every aspect of aeronautical design. Of particular interest were the advances in turbojet and wing technology. The Messerschmitt 262 had been the world's first jet bomber, even though it was designed as a fighter. It proved to be totally unsuited to the bombing role, as it simply could not carry sufficient payload to cause serious damage. But as a fighter, it could outfly any aircraft operated by the Allied air forces. Swept wings and centrifugal flow jet engines like those on the 262 would become standard features for years to come. The Germans had also explored the properties of the delta wing with the Messerschmitt 163 Comet interceptor. These and other aircraft, like the Arado 234, all signaled that aircraft design was about to enter a new era. Meanwhile, the war in the Far East was at risk of grinding towards a stalemate. Despite the imminent invasion of their own homeland, the Japanese simply would not give up, even resorting to suicide attacks against the American ships. Then, on the 6th of August, 1945, a lone Boeing B-29 Superfortress flying at 32,000 feet dropped an atomic bomb over Hiroshima in Japan. The device was a free-fall bomb timed to detonate at 1,900 feet above ground level, with a power equivalent to 12,500 tons of TNT. 3 days later, a second bomb, with the power equivalent to 22,000 tons of TNT, was dropped on Nagasaki. Japan quickly surrendered, and the Second World War was over. In an instant, the old arguments about who or what constituted strategic might became blindingly obvious: the nuclear bomb. With the coming of peace came the inevitable cutbacks in military spending, despite a mistrust of Soviet intentions in Europe and the Far East. Demobilization provided a natural means of reducing numbers of RAF personnel, but other cutbacks would hurt much more. Production contracts and, in particular, aeronautic research projects were either drastically cut back or cancelled. The lead in aeronautics and aero engine design that Britain enjoyed at the end of the war was all but wiped out within a year. For Bomber Command, this meant that the Avro Lincoln, which had replaced the Lancaster, would have to soldier on into the 1950s. But the Lincoln belonged to a bygone era. Not only was it slow compared to the new jet bombers that were on the way, it had limited range and, most importantly, was unable to carry a nuclear bomb. As a solution to this last problem, Bomber Command was to be equipped with Boeing B-29s leased from the Americans. Whilst it was undoubtedly capable of carrying an atom bomb, it was still a Second World War bomber, and not the kind of aircraft the RAF needed to take it into the nuclear era. However, there was some light in an otherwise gloomy picture. The RAF had been the first Allied Air Force to fly a jet-powered aircraft, the Gloucester Meteor. Although the performance of the early Meteors was disappointing, it provided the RAF with much valuable experience in jet flight. The Air Ministry was determined to have a jet bomber in service as early as possible. Even before the end of the war, a new specification was issued for a light bomber powered by twin jet engines intended as a replacement for the Mosquito. The result was the English Electric Canberra, which would go on to serve the RAF and US Air Force for over 40 years. Although a relatively conventional design with thick, unswept wings, it could still fly at a speed and altitude beyond the reach of the jet fighters of the day. But it could only carry 6,000 pounds of bombs, and Bomber Command needed an aircraft capable of carrying a nuclear weapon weighing 10,000 pounds. And so in January 1947, further specifications were issued calling for aircraft capable of penetrating enemy defenses at high altitude, evading interception by means of their high speed provided by jet power, and delivering, if necessary, a nuclear weapon. Despite the spending cuts, the British aviation community was led by men of extraordinary vision and entrepreneurial spirit. Men such as George Edwards at Vickers, Roy Chadwick under the patronage of Sir Roy Dobson at Avro, and Reginald Stafford and Godfrey Lee, who worked for Sir Frederick Handley Page of Handley Page fame. Their rivalry was as intense as it was productive.
At one stage, and I can't recall exactly when this happened, Handley Page design team and Avro design team decided that it would be worthwhile them comparing notes about the Vulcan and the Victor and trying to achieve the best result for the country as a whole. And a meeting was actually formed at Cricklewood with Avro designers attending and discussing, or starting at the beginning of the meeting to discuss the merits of each other's designs, when Sir Roy Dobson at Avro's found out what was going on, because he wanted to see one of the people that turned out to be Radlett, and he said, "What?" Or at Cricklewood, he said, "What's he doing at Cricklewood?" Discussing the Vulcan with Handley Page was the answer. He said, "Get him on the phone and bring all those people back instantly." And the meeting was stopped at about a quarter of the way through, I understand, and that was about the end of that. That was the way it went on, yes.
Out of the rivalry came some of the most dramatic and exciting aircraft ever to fly, brought together into a fighting unit that became known as the V-Force. The first of the aircraft to fly was the Vickers Type 660, making its maiden flight on May the 18th, 1951, with Mutt Summers at the controls. A month later, it was christened the Valiant, following a poll among Vickers employees to find a suitable name. The Valiant was a replacement for the short SA-4 Sperrin, which, due to numerous delays, had yet to fly. But it had already become clear that the performance of the Sperrin would not live up to expectations. The Valiant was far from being a pedestrian design, for by the austere standards of its day, it was an impressive undertaking, both aerodynamically and structurally. The dimensions of the fuselage were dictated by the need to carry the H-2S radar scanner in the nose, the pressurized cabin accommodating a crew of 5, and the dimensions of the bomb bay. The airframe structure was centered on a massive backbone member extending along the top of the fuselage. The wing spars branched off the fuselage backbone, giving the Valiant its muscular, shoulder-mounted wings. The wings featured a compound sweep, which meant that the angle of sweep was more acute at the root than at the tips. 4 Rolls-Royce Avon turbojets were buried within the wing root area, each generating 6,500 pounds of thrust. But perhaps the major innovation of the Valiant was the use of all-electric systems, making the aircraft very light to fly.
Well, my first flight in the Valiant at RF Gaydon, when I did the conversion, was that of size. You could tell that you were handling something much larger, but still relatively light on the controls because of things like power controls, power-operated controls. And there really wasn't a great deal different in the technique. One could say that it was a larger, like a 4-engine Canberra.
The Valiant was a remarkable achievement, for George Edwards had convinced the air staff that not only could he have a flying prototype of the Valiant ready in 1951, but that production versions would be ready before the end of 1953. This was just what the air staff wanted to hear, given the wider political picture that was beginning to unfold. The Berlin blockade in 1948, followed by the building of the Berlin Wall, marked the beginning of the Cold War.
From Stettin in the Baltic to Trieste in the Adriatic, an iron curtain has descended across the continent. Behind that line lie all the capitals of the ancient states of Central and Eastern Europe.
Soon, there would be war in Korea. Finally, the Soviets' nuclear bomb program was at an advanced stage. By 1949, they had detonated their first nuclear device. The nuclear club had a new member. The pressure was intense, but on August the 30th, 1952, the next of the V-bombers, the Avro Type 698, made its maiden flight.
Now, with respects, the day we rolled it out, on that Saturday morning, I think it was August the 5th, I forget now, 1952, and Rowley Fault flew it, the superintendent of flying, and Rowley Fault walked out of that aircraft with just his lounge suit on and his leather helmet, just as if he was going for an afternoon's drive. When he went down the runway, he lifted it, and we thought, oh no, he's not good, and he was up. He didn't lift the undercarriage, he was airborne for 2¼ hours. Now that 2¼ hours that he was airborne, he stopped the whole of the traffic in the Manchester area. They'd never seen anything like it, because it was a great Delta bomber, They'd seen the little ones flying, but not a big one like that. They all thought they were being invaded from outer space. Their telephones were red hot, police cars were tearing about, this, that, the other, because it was all kept hush-hush. We'd kept it shut up down there. He came back, he landed it, and he just got out, and he walked, and we all clapped him, and he just raised his hand, he just walked away as if he'd just been out for an afternoon's drive in a Mini Minor. Now then, a week later, he was taking the aircraft down to Farnborough to the air show, and he took off from here again on his own, and when he got to Farnborough, he rolled it like a fighter. He got a bollocking for it, but he still rolled it. We all heard about this, we thought, oh, we can't have, but he did. Now, and 10 days later, he's going back to Woodford with it. And we knew he'd arranged to fly it back at dinner time because all the crowd were outside to watch him come in with it. This marvellous aircraft that had been built at Woodford. We saw him coming. He comes over the new assembly, which is the building across the road, the assembly sheds, and he reaches the end of the boiler house. He spins it and rolls it like over the factory from one end to the other. Straightens it up in the air, shatters everything, you know, lands it and just walks away. And he broke all the glass in the roof, cracked it. And the glass in the roof was taped up for many years till the roof was redone.
From the outset, the Vulcan, as it became known, was recognized as being an extremely advanced design, both aerodynamically and as a manufacturing undertaking. The Type 698 was initially penned by Avro's chief designer, Roy Chadwick, who was tragically killed before he found out that the Air Ministry had accepted Avro's tender. In order to investigate the flying properties of the Delta wing, 1/3 scale replicas were built. Designated the 707, 2 were built to investigate the flying properties of a Delta wing at slow speed, while 2 others were built to investigate high-speed properties. However, such was the pace of development with the Type 698 program that by the time the first 707 flew in 1951, metal was already being cut for the Vulcan prototype. The prototypes were initially powered by 4 Rolls-Royce Avon turbojets, but it is the Bristol Olympus series of engines which have become synonymous with the Vulcan's staggering performance. However, further test flights at Boscombe Down revealed problems with the near-perfect Delta shape. Buffeting was experienced when pulling G at high altitude, which in the long term would shorten the fatigue life of the aircraft's structure. The solution was to incorporate a kink into the leading edge, so that the inboard sweep was reduced whilst the outboard sweep was increased. This would become the standard layout for all future Vulcans, and one which made flying the Vulcan a truly unforgettable experience.
I think the combination of perhaps the installed engine power and also a technicality that the aircraft performance frequently depends on the ratio of its weight to its wing area. The more the wing area for a given weight, the tighter the aircraft can turn. Plus, the Vulcan, the sort of triangular shape, was inherently strong, which gave it, I think, probably slightly higher G limits than the other aircraft. And certainly that combination gives you the very tight turns, plus fighter-type control column, a lot of manoeuvrability. I mean, we thought it was wonderful, and just before the Falklands, we had the Victor pilots come up and train us for the tanking. And yes, of course, their first love is the Victor, and they would defend it to their dying day. But I think they were impressed by the Vulcan. They rather liked what they saw. I remember Pete standing, we did a couple of manoeuvres, and he sort of said, "Oh, can I do that again?" And we did them so many times that the fuel got a little bit low. He was really enjoying himself. Lovely aircraft.
The formidable reputation of a 4-engine jet bomber, which sounded rather fearsome, was dispelled by the Vulcan, which was, in many ways, a very good fighter in performance terms, and beautifully easy to handle, and very few, compared with the Canberra, potential malfunctions and disasters.
As the Vulcan began its flight trials, the 3rd V-bomber prototype, the Victor, was nearing completion. The Victor would go on to be the longest-serving V-bomber, not being retired from RAF Strike Command until 1993. It was also the first heavy bomber to go supersonic.
So we did another run and went to about the same indicated Mach number, and that was it. And there were no handling problems. Everything worked perfectly normally. The whole aeroplane was smooth without any shaking. There was no evidence of exceeding Mach 1 in terms of trim changes or anything at all. The whole thing was perfectly smooth. And we returned to Radlett. And when I got back, I went into the control tower to see the air traffic controller, and I said, "You didn't happen to hear a supersonic bang at about 20 past 11 this morning, did you?" "No." So I asked 1 or 2 others around. No, nobody didn't seem to occur to anybody. So that was that. But on Monday morning, we discovered, this was a Saturday, in fact, we were doing this. On Monday morning, we discovered that there had been a good supersonic bang all over Watford and one or two other places. And it so happened that Charles Joy, the chief designer at Handley Page, had been shopping in Watford, and he'd witnessed it, and he knew what the time was. And the time coincided precisely. And so there was no argument. But, of course, the aerodynamicists immediately took all our records and this, that, and the other off the aeroplane and analysed them and said, yep, it was supersonic.
By 1945, it was obvious to Sir Frederick Handley Page that the RAF would require a jet bomber replacement for the Lincolns. Consequently, he directed his design team to begin work on a bomber design. During 1946, the design was developed into a formal proposal. At the time, there was very little data available about the flying characteristics of a delta wing, and it was thought that such a design would be rendered unworkable due to stability problems. As a compromise, Handley Page opted for a crescent wing shape.
With the crescent wing, what happens is that the inner part of the wing, close to the fuselage, is the thickest part. It houses the engines and all the structure to carry the rest of the wing. And as the wing moves out away from there, you can let it get thinner. So you achieve your high Mach number characteristics on the inboard section of the wing by sweeping it heavily. As you progress outboard, where the wing gets thinner, to achieve the same high Mach number characteristic, you don't need to sweep it so much. And so in the case of the Victor, there was high sweep inboard, and then that cut off in two stages out towards the tip. So the tips were not anything like as swept back as the rest of the leading edge of the wing, or the inboard part of the leading edge. And this achieved similar high-speed characteristics right across the wing. Didn't help the low-speed handling, but it was good for high speed, and that's what was needed.
By April 1948, the design had been refined sufficiently for a contract for 2 prototypes to be built. The Victor, as it was now named, was to be powered by 4 Armstrong-Siddeley Sapphire turbojets, each capable of delivering 7,500 pounds of thrust. Like the Valiant and the Vulcan, the engines were buried deep in the wing root. The wingtip fins were soon dispensed with, and following advice from the Royal Aircraft Establishment at Farnborough, the tailplane was moved from its mid-position to the top of the fin. The tailplane was a huge fixed section with a pair of large elevators. Its span was just 11 inches shorter than the wingspan of the Hawker Hunter. To explore the characteristics of their design still further, Handley Page decided to construct a piloted flying model, the HP-88. The exercise proved to be almost pointless, as the Victor program continued independently of the smaller research vehicle. Not only was the Victor aerodynamically advanced, it also pushed back the frontiers of manufacturing knowledge. The Victor was constructed using a honeycomb sandwich riveted or spot welded to the wing and fuselage frames. Not only was this immensely strong, but also very light. The first prototype was assembled at Radlett in anticipation that this is from where the Victor would make its first flight. The Ministry of Supply, however, was concerned that the runway was not long enough and demanded that the aircraft be transported to Boscombe Down, disguised as a boat. Amid great secrecy, the Victor was assembled and made ready for its maiden flight.
We didn't know anything about it until B Squadron's hangar, which was the one that I was working from, had to have a lot of space cleared in it suddenly. And we didn't really know why, but on the Monday morning when we came to work, we discovered the reason was that it was full of chunks of Victor, and that people were busily, even almost immediately, starting to put this thing back together. And yes, I mean, the whole thing was still terribly hush-hush, but then the whole of Boscombe Down was, you know, everything was sworn to secrecy. You weren't allowed to go outside the place and talk about it, but you could talk about it inside the place. They couldn't stop us. It was in our hangar, and we began to see this thing being built. And it was really quite a revolutionary affair, I can tell you, in those days, for a big aeroplane. I mean, swept-wing aeroplanes were about for small ones, but for a big aeroplane, this really looked quite fantastic. And then we saw the outer wings put on with these great chunks of nose flap hanging down. That looked quite extraordinary in those days.
Then, on Christmas Eve 1952, the conditions were just right, and the Victor took to the air for the very first time with Chief Test Pilot Squadron Leader Hedley George Hazelden at the controls. The Victor flew as well as it looked, and in the years that followed would leave an indelible impression on all who flew it.
Well, once again, not unlike the Valiant, it was immediately a super piece of equipment to fly and comfortable, and you felt at home with it straight away. And fairly soon after I started flying it, I was able to take it to high altitude, and I quite early on had it up to 50,000 feet without any trouble, much more easily than I'd ever had anything else up to that height. And the only previous aeroplane I'd had that high was a Camber in Boscombe Down days. And it got there much more easily. And the other great thing about it was that its Mach number capability was so good, it didn't have any, or at least any apparent compressibility problems. At any Mach number up to about 0.93, which was really going some in those days, because most aeroplanes were getting into trouble around 0.82 Mach number.
On the 15th of July 1953, the Victor made its public debut at the Queen's Coronation Review at Odeon. As wave after wave of aircraft flew by in salute, the newly crowned Queen Elizabeth must have marveled at the strength and power of her Air Force. Soon the Meteors and Vampires would be replaced by Hawker Hunters and English Electric Lightnings, providing the country's aerial defense. The Washingtons would be returned to America within months, as Britain now had the makings of a modern jet bomber force that could rival any other in the world. All that was needed now was a nuclear weapon to guarantee Britain's status as a superpower. The assumption that it would be an American nuclear bomb had been abruptly cut short in 1947, when the US passed the Atomic Energy Act proposed by Senator McMahon. The act prohibited any further cooperation with Britain over atomic research, despite the role played by British scientists in building the first American atom bomb. The chill caused by America's isolationist policy left Britain no alternative but to develop her own nuclear arsenal. On the 11th of October 1956, a Valiant successfully dropped a 10,000-pound Blue Danube freefall bomb over Maralinga in Australia. The following year, Britain's first thermonuclear, or hydrogen bomb, was dropped 400 miles off Christmas Island in the Pacific as part of the Operation Grapple tests. The third of these drops produced Britain's first megaton detonation. Britain's place at the superpower table was now assured, and America keen to rebuild a special relationship.
Don't you hear the H-bombs thunder, echo like the crack of doom, while they rend the skies asunder, all out makes the earth stood.
The aircraft was painted in a special anti-thermal flash paint. There were no black dielectric covers for the radar components on the outside. This was all, and even the flying controls, the seals on the flying controls were all made of a special anti-radiation neoprene material. The other item of equipment which was very essential was we had to black out the whole of the crew cabin. And so at a certain time prior to the bombing run, all the blackout screens went up, so the whole cabin was sealed. The only small slot was immediately in front of the captain on the left-hand side, which was a very heavily smoked glass screen, a matter of 3 or 4 inches by 1 inch or so, very small slot. Now, on the explosion of the weapon, we felt this in the form of 2 shock waves. The first one was the immediate air blast, and this affected our instruments in that the vertical speed indicator went to full-scale deflection, i.e. 4,000 feet a minute down, and then settled back again to 0. The second shock was the reflected ground wave, several seconds later. And it did shake the aircraft, there was no doubt. It was quite a thump that we felt. By this time, we were going away from the explosion. We had our tail towards it, having completed an escape maneuver. And this escape maneuver involved turning through, I think, about 135 degrees and pulling an exact amount of G. We had a very accurate accelerometer fitted, and I believe it was something in the order of about 1.7 G. Not a lot, but at that amount of G, we could guarantee to have completed the escape maneuver. And so immediately we had completed the escape maneuver, down came the blackout screens, and there we were able to see the results of our efforts. This huge mushroom cloud way up into the stratosphere.
The first Vulcan B-1s went into squadron service with No. 83 Squadron, based at Waddington, in July 1957. In April the following year, No. 10 Squadron at Cottisman became the first operational squadron to receive the Victor B-1. The V-Force was complete.
It was very exciting. I think that's more the word. Thinking back, I suppose we did feel that we were entering a new era in operational flying.
There was a great air of expectation and pride at being selected to fly these new bombers. One considered oneself in the elite, if you like.
It had been obvious for some time that getting a free-fall bomb to any sort of Soviet target would be almost suicidal, as the Soviets rapidly improved their defensive capability. The answer lay in standoff weapons, missiles which could fly themselves to the target after being launched from an aircraft. In March 1956, Avro was awarded the contract to build Blue Steel. Blue Steel was 35 feet long and carried a red snow thermonuclear warhead. It used rocket propulsion and had a range of 100 miles. A Valiant B-1 was used in the early trials, which, despite some initial setbacks, were extended to other V-bombers. By 1963, blue steel was ready to go into service. However, a Mark II version was already in development, which would have had a much longer range. But progress was slow, and it was cancelled in favour of the Douglas Skybolt from America, which was scheduled to replace blue steel in 1965. It transpired that the Victors could not carry Skybolt, so Avro began to adapt 72 Vulcans. These were the new Mark IIs, which had arrived in service at Christmas 1960. These aircraft had a more powerful engine, the uprated 16,000-pound Olympus, which could push the Vulcan up to Mach 0.98. An enlarged wing, which gave it an improved service ceiling of 55,000 feet, as well as a host of new electronic countermeasures equipment. But the RAF's plans went awry in November 1962, when President Kennedy cancelled Skybolt.
The problem with Skybolt is it's the most sophisticated weapon imaginable. We put $500 million into it already. To fire a missile from a plane moving at high speed.
Following much diplomatic and political manoeuvring, Kennedy agreed to let the British have the submarine-launched Polaris. The timetable for the demise of Britain's airborne nuclear deterrent was set. In the meantime, Bomber Command would continue with blue steel and free-fall bombs. By 1963, NATO's response policy to the Soviet threat was in place. The bulk of the strategic responsibility was placed on the shoulders of the awesome American Boeing B-52s of Strategic Air Command. They were supported by batteries of medium-range and intercontinental ballistic missiles. Europe's contribution to the nuclear deterrent rested solely with the V-Force. A tripwire policy meant that any Soviet aggression would be countered by a massive nuclear strike. This meant that British bomber crews were always on instant readiness. Quick Reaction Alert, or QRA, was designed to disperse the aircraft to airfields around the UK. There, the crews would live either in readiness huts next to their aircraft or in the aircraft themselves.
Captain to AO, timing checks, oxygen, Captain, co-pilot, Papa, radar, AO, content 7X.
Life was fairly tedious. There's no getting away from that. You sat around for 24 hours or went to sleep in a caravan, waiting for the whistle to blow. But it was an opportunity to do other things. Of course, you did quite a bit of target study while you were on QRA. And that was simply sort of locking yourself away in a secure room and getting your target material out and working on that.
Essentially then you would deploy the aircraft to wherever, set yourself up, and you'd end up with 4 aircraft on the ORP, fully fuelled, weapons as required, not nuclear weapons for a dispersal obviously, and we'd be plugged into what they called the tele-scramble, which if you like was a phone all the way back to Bomber Command. The crews would be sitting in, we had little caravans that were taken around if there was no purpose-built accommodation, and you'd sit there, and in the background, I always remember, you'd have this beep about every 10-15 seconds, which was just to prove that the line to Bomber Command was still open. And then at the appropriate time, which you'd always try and second guess and usually get it wrong,
there'd be a message from Bomber Command, or Strike Command as it became, raising the alert state. Now, the normal alert state was called Readiness 1.5, and at Readiness 1.5, that meant you were in flying kit, you were in the vicinity of the aircraft in the caravans or having a meal, and 1.5 meant you had to be airborne within 15 minutes. They could then raise that to Readiness 0.5, which meant you had to be airborne within 5 minutes, so for that, you would go out to the aircraft, strap in, do some preliminary checks, but wouldn't start the engines, because if you start the engines, you're burning fuel, which of course limits the time. There was up to 0.2, which was airborne in 2 minutes. For that, you did start the engines. Of course, there's a finite time then of how long the lords and masters can hold you at that alert state, and the ultimate one of scramble. And the normal one for us was Readiness 0.5 would be called. A few minutes after we got into the aircraft, they would scramble us, and then everything worked extremely well. The aircraft was designed, one button, press that, all 4 engines start, the powered flying controls run up. Everything was designed to automatically snatch out the back. You didn't bother with unplugging anything, just opened the throttles and went. In theory, the number 1 aircraft went first, but if he was delayed, he'd be elbowed out of the way by the number 2, and you just went. And as soon as you're airborne, start to disperse in the air to get out of the way of any incoming missiles. And certainly, Readiness 1.5, no trouble at all. If you said scramble from Readiness 1.5, we'd be a bit upset if people weren't airborne within 6 or 7 minutes if they were living close to the aircraft. Maybe 10 minutes if they had to take a transport out there. It was good. It was practiced regularly. It worked.
The essence of V-bomber operations and the aim of all crew training in the past had been to fly and launch missiles from high level. But in May 1960, new evidence of the development of Soviet missiles emerged. Then, an American U-2 spy plane, piloted by Gary Powers, was shot down by a surface-to-air missile over Soviet territory at a height of 65,000 feet, a full 10,000 feet higher than the operational ceiling of the V-bombers. This, together with the cancellation of Skybolt, effectively signaled the end of high-level operations. Over the next 3 years, procedures were revised to bring operations down to low level, first at 1,000 feet, and eventually, when conditions allowed, as low as 50 feet.
One of the beauties of the Vulcan was, of course, it was extremely responsive on the controls. You could handle more like a fighter. You even had a fighter stick, even though a great big wheel. So the low-level operation didn't actually cause much of a problem.
Although blue steel could be launched at low level, new methods had to be devised for free-fall bombs. This led to the use of the Labs maneuver, which exploited the handling characteristics of the V-Force aircraft to the full.
In the show in 1958, we demonstrated a low-level run across the runway, pulling the aircraft up into a half loop and rolling it off the top. And the excuse for doing this was, yes, it's a demonstration of a Labs maneuver. The whole maneuver was done entirely inside service limits for the aeroplane. We didn't exceed the service limits at all. We used the maximum speed that the aircraft will be cleared to service for, which was 360 knots. And in the loop, or the half loop, we pulled 2G, which was also inside the service limits. Rolling the aircraft off the top, of course, doesn't exceed anything. It's an entirely 1G maneuver. And so, okay, it just made something good to look at Farnborough for a big aeroplane to do. You could only do it if the cloud was reasonably clear, because we went into the bottom of this thing at about 500 feet and over the top at about 8,000 feet.
But there was to be a price to pay. The conditions at low level meant there would be thicker air and more turbulence, putting more stress on the aircraft's structure. This would inevitably shorten its life, and the first to suffer was the Valiant. Having flown low-level operations for Strategic Air Command Europe for 2 years, already the Valiants began to show alarming structural problems. In December 1964, a routine examination of one Valiant showed fatigue cracks in the main spar. A rapid checking of all other aircraft revealed the same problem. There was no alternative but to ground the whole fleet of Valiants from early 1965.
We heard all about this, the famous incident at Gaydon, where one of the flying instructors was flying a sortie, and there was a tremendous crack, and one of the spars on the right wing, I think it was, actually broke. They were able to reduce speed, fly back to Gaydon, RAF Gaydon, near Leamington Spa, and the crack was so bad that in fact it disconnected the drive to the right, to the starboard flap. So one flap came down and the other didn't. And so the captain very quickly realized that this was it, and so he rolled his flaps back in again, because obviously the aircraft was starting to roll quite badly. And they landed this aircraft. He did a magnificent job of getting it down onto the runway, flapless. When the crew stepped out, they all walked round to the right-hand side, and they saw daylight through the wing route of where the starboard wing was joined. And that's how lucky that crew were.
The grounding of the Valiants was not without some irony, for even before the first production B-1s had been delivered, a special low-level B-2 version had been built. It had been ordered at a time when Bomber Command felt there was still a role for its Pathfinder force, but was soon cancelled when it was recognized that dropping nuclear bombs did not require that degree of accuracy. Had it gone into operational service, then it might well have been the Mark II versions of the Vulcan and Victor that found themselves redundant following the decision to go low-level. The grounding of the Valiants and the transfer of the nuclear deterrent to the Navy at some point in the future did mean there was a need to reorganize the way in which the V-Force functioned. Admittedly, there were some cutbacks in orders. The Mark II Victor, equipped with the mighty Rolls-Royce Conway engines, was the first to suffer when almost half the order was cancelled, leaving the RAF with only 34 of them.
When the Mark II came along, yes, that was absolutely superb with the amount of power we had. The original Conway 11 wasn't the definitive engine for the aircraft. The definitive engine was the Conway 17, I think I'm getting my numbers right, and it delivered 20,500 pounds of thrust. And that flew just about a year later, and subsequently they all had the big Conways in them. That really gave the aeroplane some oomph. For instance, you could sit a Mark II Victor on the end of the runway, and provided that the radar air traffic controllers would give you a clear climb out, open up the power against the brakes, and at about 85% power, the airplane was going to move anyway. It wouldn't hold it. The brakes didn't slip. It was just dragging it along the ground on the tires. So you didn't let it do that. At the moment it started to want to move, let go of the brakes, hit full power, and from the moment of letting the brakes go, you could consistently have that aircraft out of 20,000 feet in 2 minutes and 8 seconds, and up to 40,000 feet in 8 minutes. Now, for an aeroplane of this size, this was really performance, without a doubt.
But the V-Force would continue for 3 major reasons. Firstly, TSR-2 had been cancelled amid controversy and recrimination. With no credible replacement in sight, it was left to the Vulcan to maintain the RAF's strike capability. Secondly, NATO put pressure on the British government to retain the V-bombers as tactical strike aircraft to counter the threat of the huge Warsaw Pact ground forces in Central Europe. Finally, in-flight refueling techniques had been perfected during the 50s using Valiants as tankers. The ability to refuel in flight greatly extended the reach of the RAF, enabling it to give up bases in some of the more far-flung reaches of the globe. Fighter Command had also come to rely on in-flight refueling to extend the range of its frontline aircraft. When the Lightning came into service, it had an endurance of little more than 40 minutes, an impractical proposition without the ability to refuel. With constant top-ups from the tanker, these aircraft could fly almost indefinitely. With the loss of the Valiants, the role was assigned to the Victors. Almost immediately, every available Mark I was converted. The first 6 were equipped with 2 retractable refueling hoses in pods under the wings. The next 25 had a third hose fitted into the bomb bay. By the end of 1966, 3 squadrons were fully operational as tankers. In 1968, the Victor was withdrawn from the bomber force altogether because of the impending delivery of Polaris to the Royal Navy and because of the uncertain future of Handley Page aircraft. Ironically, the contract to convert the remaining B-2s to K-2 tankers was awarded to Avro. The reach of the V-Force was demonstrated to dramatic effect during the Falklands War in 1982, when Vulcans, refueled by Victors, flew the longest bombing mission in history.
Part of the deal of the Vulcan is a threat, and we'd made it clear that we physically had the ability to bomb the Argentinian mainland, so the Argentinian Air Force had to reserve a fair proportion of its fighters to defend the homeland. This means that when they put their A4s in against the fleet, they essentially were going in unescorted. And the aircraft that could have been there and interfering with the operations and taking out the Harriers were being held back to defend the mainland. Again, one of the contributions that the Vulcan made.
The Vulcan was already being replaced by the Tornado GR-1, and the RAF also had Buccaneers, which could fly low-level bombing missions equipped with the latest weapon guidance technology. But neither aircraft could carry sufficient payload that distance. Preparing the Vulcans had to be carried out in record time.
We trained at 43,000 feet and 500 feet. It was such an unusual thing that when they were looking for statistical figures to work out bomb dropping, they actually had to go back to the B-29 missions over North Korea during the Korean War. That was the last time medium-level bombing had been done. We didn't have tables for those kind of... A lot of things had to be dug up. And in fact, the Vulcans, of course, were going out of service. As we were bombing over the Falklands, they were breaking up Vulcans at Waddington. And a lot of the equipment that we were carrying down with us had actually been rescued from the scrap heap. There were people who had never done £1,000 bombing in their lives before. And again, we had to find one of the very, very experienced nav radars who was briefing people on kit that, of course, had been his life in the 50s and 60s and 70s, but he never thought he was going to be trotting this information out in the 80s. Never throw anything away. You never know when you might need it.
No less than 11 Victor tankers were needed. On each sortie, the single Vulcan was refueled 5 times on the trip out and once on the way back. The Victors themselves needed to be refueled 10 times. The pilot on the second sortie was Squadron Leader John Reeve.
There was very little radar activity, quite frankly, over the islands. We cast off at about 250 miles north of the islands and dropped down to low level. And again, no one was for one moment doubting that the Argentinians were a fairly professional force. I mean, their pilots are as good as anyone, no suggestion there. But What we felt was, if you're going to intercept an aircraft at night, an awful lot of things have got to go right. And they've got to go right on a very technical level. And while I had no doubt about the Argentinian pilots, we were not convinced that the Argentinian conscript technicians could necessarily, do the little technical things, make sure the generator's at exactly the right frequency so the radar picture is perfect, that the radar is correctly set up. And certainly when we went in very low level to avoid the radar. We then climbed up to about 14,000 feet and bombed from that height, which was above the effective range of their light anti-aircraft guns. It also had the advantage that the bombs, when dropped, would strike the runway nearly vertically, so there was no possibility of them bouncing off. They would penetrate well through and blow up in the subsoil and really heave the runway up. So we were not picked up by the radar, and to some extent I'm not surprised in that to operate a radar on the Falklands 24 hours a day in those conditions is not easy. I'm not sure the very finest Argentinian troops were put ashore, and we felt by day I'd have been very, very wary of going, but by night, when everything's got to be a technical thing, we felt we were in with a reasonable chance.
But this really was the last gasp for the Vulcan, and in 1984 they were removed from operational service. One example was kept flying, performing in many air shows when it dazzled the crowds with its noise and fighter-like maneuvers. Then in 1992 it too made its last appearance. The Victor was the last of the V-Force to leave RAF service. Serving into the 1990s, it performed sterling service in the Gulf War, refueling not only RAF aircraft, but those of many of the coalition partners. Alongside 10 VC-10s and TriStars, the 7 Victors took their share of 299 sorties in just 42 days, helping to deliver 13,000 tons of fuel to the thirsty strike aircraft. For 38 years, the skies of Britain shuddered under the noise of these great four-jet-engined bombers. As conventional bombers, nuclear carriers and tankers, they performed their tasks with style and grace. Although designed to meet the needs of the Cold War, they represent a pinnacle of aviation design. As to whether the airborne nuclear deterrent was justified, who can say? History suggests that it was. It provided a reason for the Americans to continue the close relationship with Britain, and thus guaranteeing the safety of Western Europe for 40 years. As to the cost, one should heed the words of Sir Frederick Handley Page when he said, "Nobody has ever won a war by trying to run it on the cheap. Nothing is so expensive as losing a war by saving money." If you want the cheapest possible air force today, it is very easy to standardize on a whole lot of aircraft, which will be of no use when a war comes.